So I don't have enough USB ports for the clicker. I don't think.
Okay.
So I'll just tap. If that's okay.
Next. We just say next. Yeah, it's strange that they don't do actually. They could have done an addition. Do have a USB.
Extension.
Yeah, I think so. No, well, downstairs. Yeah.
Say when.
I will do. Sorry everyone, I'll be with you in a moment. Right. Sorry about that. Ready when you are, Adam. Francesco. Thank you.
Hello, good afternoon everyone. We're going to be talking, so I'm Adam Jaworski and I'm going to be presenting with Francesco and Selma, and we're going to be talking about smart buildings as a subject. It's concurrent topic, a topic in our industry at the moment. But to draw some distinct directions or conclusions about how we feel it should affect our industry and how we as designers should respond to that. Just a description of how we're going to structure this. I'll make some opening comments. We're going to have a video from one of our clients, Google, and our specifically Kathy Farrington, who works there and we've been working with for a number of years now, has put up a very cogent video which she recorded at the end of last year, and which really sets the scene from the perspective of that organisation, how they see the field developing. We'll then move on to some specific topics drawn from her comments. Francesca will talk about software defined buildings and how we might name entities within the buildings. I'll talk about some work we've done on the specification to help our MEP teams specify these systems, and we'll conclude with a little example from an ordinary project to illustrate how this could affect everything we do, just a conversation about smart buildings. So if we could move on, Tom, with the first slide. I wanted to point to this. This is something that we get criticised as an industry, our productivity. And construction is a red line running along the bottom of this diagram. It's sort of really depressing. This is a US diagram. I've got another slide coming up in a moment, but just to point out, manufacturing 8 times at least productivity relative to 1950. Utilities 6 times, agriculture 6 times. But construction is flatlining. Tom, next slide. And UK, this is another source. There's many of these studies have been done. UK and Germany, pretty much the same story. Slightly better than the other diagram, but only slightly. Maybe 5% improvement in UK productivity since the mid-1990s when I started my career in engineering. Not a great record, and I want to just cast this thought to you that part of the problem is, in MEP at least, our control systems and the way we commission them, the way we integrate them, the way we operate them, is non-productive. There's huge improvements available if we as an industry sort it out and take advantage of these new technologies. So with that thought in mind, I think we'll move on to the video itself and just hear what Kathy has to say. Thank you. We're going to edit this later, so the gaps will be removed.
Yeah, perfect. Nice.
Here's one I prepared earlier.
Hi, my name's Kathy Farrington. I'm from Google. I'm a technical program manager, and my previous background was designing smart buildings for various companies and the ICT infrastructure for them. So today I wanted to talk about a standard for smart buildings. So smart buildings have been around for a long time. People have been talking about them for years, but there's still very little standardization when you look across the various systems within a building. So anyone you ask in the industry on what a smart building is, they're going to give you a different answer. They're going to say some people are going to be very focused on energy, others will be very focused on space utilization or productivity or automating repetitive tasks. But what a smart building is all of that. It's everything that we want to be able to do in a building, to be able to link it and create the next level of what buildings are to us. And other people you'll ask, what are the problems in a smart building and why has it taken so long to take off? These are kind of the three key ones that I've seen, but there are many others. The first being security. So everyone's seen all the IoT security issues out there, the newspaper articles of the hacks and things around IoT security. So that's a very big one that needs to be addressed. The second is scale. So buildings are still being designed in isolation. They're still being designed by the people that, the engineers or the architects or whatever that are on that specific building, with very little influence from others relating to these systems. So how you scale that on a global scale or within an organization is really difficult. So scale is another issue. And the last one is insight. So we've already got so many of these devices within our buildings. There's so much of this data, and there's no way to be able to get insight from that data right now. So I keep asking myself, why are we approaching buildings in the same way that we have been doing building automation? Why are we approaching smart buildings in the same way we've been doing building automation for the last 15 years? Which is this. Basically, all the different systems designed in isolation, designed in silos and separated with different infrastructure user interfaces and data. So what I wanted to propose today is, should we not be approaching the buildings horizontally rather than vertically? So the basic concept is any device can talk to any application and vice versa. So rather than coming into a building and going, I'm putting this device in and it's part of the BMS, you just start thinking about devices as IoT rather than HVAC or lighting or whatever. And if that's the case, any application can then use that data that's coming out of that device. So going top to bottom on this, the device, and I'll go into detail in the next slides, but the device side means that we need standards, we need open, we need security, we need to start having a way that we can actually you do this consistently across all different disciplines. The connectivity platform, the key on this is security and making sure we can create connectivity in a way that's not going to compromise enterprises, because the only way it is going to scale is to converge those networks. On the data lake side, we want all the data that's coming out of these devices stored in a central place, which is pretty much cloud. So it's a cloud-based data storage or data lake, and being able to store those and make it accessible to any of the applications that want to use it. And then it's basically open to anyone that wants to make an application, use the data, use the system. Any of the current applications out there can be used, or new ones. It basically breaks the model of needing to understand everything in the infrastructure to be able to create the application in this space. So these are kind of the key learnings or success criteria I feel need to be achieved to be able to hit the horizontal, because it's obviously a long-term vision, because it's very different to the way we currently build and design buildings. So the first is the skills gap. So when you're talking about IoT and smart buildings, you're talking everything from construction, mechanical, electrical, FMs, people who are actually building and maintaining these buildings, all the way to your detailed IT systems. So people that are doing data scientists, application developers, IT network people. And that's a huge range of skills that are required to build and maintain one of these buildings. And the second is the construction industry is built and designed on waterfall type method of program management. So you design something 5 years or whatever before you actually deploy it. And in that case, that means that a lot of your systems and your devices are locked in 5 years before. And if you go to any software developer and say, your software has to be exactly the same in 5 years, you're going to get laughed at, because that's just not how the industry works. So working out ways that construction and moving the devices that are actually selected and going to be used for device, any sensing, monitoring or control back into later in the construction program is kind of key to hitting this. The second one is security. So I mentioned that this is one of the big drivers, and I've been to a lot of conferences and seen a lot of white papers, and everyone's trying to solve security right now. And for me, the best ones that I've seen are device profiling. So if you're an enterprise, you want to know what that device's purpose is. You want to know what data traffic it's doing, what it's supposed to be doing, and how it's supposed to be operating. And you're not as the IT team or whatever, you're not going to know or understand that device. So the only person who can do that is the manufacturer of the device. So if the manufacturer provides a device profile, you can then limit that device down to what it should actually be doing and the traffic's actually doing. And when it's compromised, it can be isolated, restricted, whatever you want to do within your security. I've put a URL in there for a draft IATF standard called MUD, and it's manufacturer usage description, and it's basically doing exactly what I'm saying, along with some other things, but it's basically putting the onus on the manufacturer to create that device profile. I've also put a link into a white paper that we've written at Google on application security requirements for IoT devices. And this is about taking the best practice IT practices and pushing it to devices. So everything like making sure you're updating your devices, to making sure you're using encryption or certificates, or actually disabling things on the device that you don't need. Because so many of these devices have everything enabled just to make life easier, but from a security perspective, that's an absolute nightmare. So it's worth reading and having a look at that white paper to see some of the recommended best practices. And if you're IT, it's basically the same kind of practices that have been in place for quite a while. On the device side, you think about all these devices in your buildings and how many are predicted to be in the buildings in the future, and who's tracking the life cycle of those devices. And when I say life cycle, I don't just mean the purchase and the decommission or that. I mean the hardware, the software, the firmware. When was it last updated? When is it going end of life? How are these different things being maintained? And the answer in a lot of cases is there isn't anyone that's tracking that kind of level of detail. So getting a robust asset management and life cycle management system around these IoT devices is really key. And the other one on the device side is that these devices have been built and designed around protocols that are designed for local. They're designed for being used within a building. If you're trying to connect these into the cloud or outside your building, you need to start moving towards the IoT protocols like MQTT rather than using things like BACnet, because that kind of traffic is not what you want to be going over the internet. So a lot of what I'm saying comes to standards, and I think one of the key things that I wanted to kind of stress is that these buildings are being designed and built not necessarily by the people who are using or running them. They're being designed and built by design teams who want input from the customer but are not getting it. And if you think about like an IT organization, every laptop, phone, mobile phone is highly regulated when you're going to put it on your corporate IT, and then we have all these other devices that are not regulated and don't have company standards. And so it's really key to start saying, I want these to be open. I want these to be secure based on these requirements. I want to own the data within my building. All those are really key to being able to get a project moving forward. And one for the device manufacturers. A lot of these devices are used to having really unreliable networks. So they've actually tweaked in a lot of cases the standards, so the RFC, the IEEE standards, and said, no, we're actually going to not do it that way because we can't rely on the network. But when you're moving towards enterprise and smart buildings, the network is way more reliable. So you can't hold, like an example is DHCP. A lot of the devices hold their address too long. And that's not the way they should be managed. They should be designed and built the way the standards are actually designed to do. Connectivity is another one. So if we've got device profiles, the only way you're really going to be able to lock down your networks to the way that you need is designing around software-defined networks. And the second is to design your networks for users and devices. I mean, networks for enterprises have been designed around people, but the number of devices that are going to be connected to those networks could potentially be significantly higher than the number of users. And the last one is around the data. So if we've got all these different systems, the only way we're going to be able to create actionable insight is to understand the relationship between the devices, what they impact, physical and logical, and also understand how that data is structured so that you can actually do something with it. So standards around schemas and relationships. Brick is an example, which I've put the link in, where they're trying to do this. So there's lots of other things here, but I kind of really wanted to just say, as a company, whatever you're doing, you start with the standards. Start telling the people in the industry what you want and how you want it. And then that way you can actually do something with the building once you get handed it. Thank you.
Okay, so moving to the next part. So what Kathy has presented is actually happening. So there is a team in Google working on creating the part of the software and architecture to go with that vision. Part of that was organizing a workshop with device manufacturers coming from all ranges, mainly control manufacturers, but to start this conversation with the industry, because this is about transformation. Part of that, so next slide, was discussing on standards, and the approach, and if you want to quickly read this, is that this effort is not about creating new standards. This effort is really about trying to see what is available and pick up the things that are working the best together. To steer the conversation forward, we created a paper. So this paper is a collaboration between Google, Arup, and NBY, and it sort of sets the vision. And actually, it's quite practical to some extent in creating a organization of what a smart building could be with these ideas. So there are 5 areas of definition, and one is about testing. So it's the kind of here. So it talks about ecosystem first, because it is before the smart building can be created, there needs to be an ecosystem of devices and manufacturers who can achieve this. And this needs to scale. So it's designed for scaling. It's designed, a little bit like. If you think about Android, it wasn't existing, and suddenly we have, every one of us has mobile phones in our pockets, which work exactly like this. They scale to millions, and it's the same thing in this case. So 5 areas: organization of testing, physical representation, network communication, telemetry ingestion, and software-defined building. Some of these follow a language that is very IT defined. So one of the strong idea of this approach is really that bringing the best practices from IT into the way we design and control buildings. So these 5 elements can be sort of translated a little bit more easily, maybe, for our own into our own language. So one element, so the testing part is so important. It is about security, and it's the fact that it needs to be continuous. You can't expect a piece of equipment being there for years without knowing its state through time. Another aspect, physical representation. We need to name things so that they can survive from design into operation, and then through operation through time as well. So if anyone has been working with cloud infrastructure, so you know how easy it is to spin a machine, connected to create a network interfaces and so on, like totally in a software-defined way. That's the sort of idea that has been brought by software-defined networks. You don't have a little guy going into the switch and programming, accessing the console and programming the switch. You just do it from one single location. And so that's something super important for scaling up. And in terms of sharing data and metadata, it's important to make the best use of standards. I mean, we showed the previous slide, it's in that ethos. And the outcome of all of this then is that we can program our buildings. Right now, programming is totally fragmented. You don't have the possibility of saying, telling a building to do something, connecting different portion of it, especially across systems. So I'll go to the next one. So this level of standardization, I think Kathy mentioned before an article. You can start reading the bit that is about testing already into an IEEE article that has been published. And in the next few slides, instead I'm going to focus a little bit more on the naming part, which is the bit that so you can move to the next, the bit that I curated during that workshop. And so the topic is consistent naming from design to buildings in use. So I don't know, I mean, most of us will be familiar with Chinese whispers. I learned that in the States it's called telephone. And you start with an input and you end up with an output, because language translation is, is tricky, right? A message can get different. And then the problem is that it ends up, creating, things that, in some cases could be quite damaging. In other cases, it can be nuisances. It can have a whole range of things. So, why is this? So this is because the message doesn't go across. So how can we make the message go across? So through all these design stages, from brief strategy to operation, we have a number of players who starts work in different stages. I mean, this is just indicative. Obviously, it could be much more complex. But in all of this, there are efforts right now to create a digital representation of things in buildings. And so, especially between designer, contractor, and supplier, there are ways of modeling things and modeling devices and using different software tools. When objects, things get into buildings, they start getting modeled around the developed design. So around that time, where the level of detail of the building is already getting to something recognizable in terms of spatial representation, physical representation, and then it gets developed further and further. Now, there are 3 key elements that needs to happen in order to have this seamless data sharing between between phases. We mentioned use of open standards to represent physical devices in 3D representation, but also data representation. Key element is to keep the device identity consistent across phases, and then transfer parameters from design model to physical labels and metadata, so that we don't reinvent the wheel every time. So across these phases, usually there is a big gap. I mean, we try now to move BIM model across phases. But the thing is that even a BIM model is not something that an operational person would need. So we identified as part of that workshop 3 key technologies. I mean, part of bigger efforts. One is IFC, that looks into standardizing a BIM. across different software. And it's possible to, it's totally programmatic, so it's possible to be parsed and to be translated. In construction, passing data from BIM to things like naming and labeling, which can happen as well in programmatic ways, such as QR codes and NFC tags, barcodes, and so on. And then moving the data model into something that is more expressive for operations. And the best model is the human brain. And on the human brain, there is a standard of the semantic web which has been built. And schema that are designed for buildings, such as brick, are what is going to be used. So next one. This is a simple example of trying to attempt this this moving between BIM model to labeling to operational models. I mean, it doesn't mean it is exact, but it is an example of what needs to happen. So there are objects that already standardize unique identification that then can pass through construction and then can be injected into the names of objects inside operation. So there is a system called brick that is able to, in BIM, no one would model an endpoint like an input-output of a device. While in here, we can model input-outputs of devices, so we can have a full description of the building, which then can be programmatic. So we can create it before, instead of doing spreadsheets, we can create a network of how things are connected, and then push it to the building. That's the sort of idea. Next one. This is another example that shows how right now everything is left to manufacturers. It was really to say that if we can achieve some simple standardization in the way things are named, we could even pass it a little bit lower down to system integrators or even to device manufacturers, so that if the data model is shared, then labels can happen very, very easily directly by at manufacturing level. So next one. And there are two elements that are quite important in this process, going from when libraries are used to create a software down to operations. One element is testing. We need to ensure that models are not, because there is always human error, right? Whenever something is authored, we need to ensure that models are validated. So naming is consistent, unique, and so on. But also we want to reuse. So these are the 2 points about naming. 2 and 3 that I mentioned before. The translation happens so that we don't lose all the good work that has been done in modeling things when we create the model of the building. And there is a last slide that I showed as an example of a very simple model where I was really going into all the names and so on, but also, I was browsing while I was doing a little example, a little test, but also I pointed out that there are already a lot of tools that is possible to use in an open environment. And I think this one is the last slide about the naming.
So we appreciate, all of us, that we're in a time of transition for our work, and the next 2 portions of the presentation is really about tools that help us as designers move our projects in this direction of what I like to call clean data and cloud services and applications, but without it costing an absolute fortune. Just thinking back to how I opened today with the productivity question. So what we've learnt over attempting a number of automation specifications is that there's some standard things we can ask our contractors for, and we put that through and invest in our sponsorship into a specification that we'd like to share with the MEP disciplines primarily, but also other specialists. And I'd like to show you that briefly now, and we are aiming to have more conversations with each individual discipline. We started last week with senior mechanical leaders. So Tom, if you mind opening the link. So we've got, and you can follow the link, it's not secret or anything. If you go to the presentation, those of you watching afterwards, the link will be there. And Tom, if you just scroll down, just the normal Arup format, the individual skills networks will decide how to extract information from that. We're part of the debate with them. But the topics we cover in this spec are IP networks, and that means wireless as well as wired networks that can scale over the internet, which is a difference to our normal designs where they're just bounded by the building. We cover, therefore, security and encryption and authentication topics, which traditional MEP designs don't have. We cover the naming of devices, which Francesco illustrated a moment ago. We cover access and GDPR, the actual who is allowed to access this data, who owns the data, data controller, data processor, that side of things. And actually the mechanics of what clean data is. JSON, MQTT, these technologies are explicitly referenced in the specification. And the whole thing is meant to set up our projects for lower cost horizontal integration of systems. So if you scroll down, Tom, there's a diagram which shows the systems.
Is it far down?
Not too far. Coming up.
After the preliminaries.
After these definitions. So you notice RFCs, these are internet standards, and key, Kathy pointed out, we need to reference standards that exist for the IT world and bring them over to the OT world. There you go, stop there.
There's another one?
Yeah, the next one. Go one more.
Should have been before, I think.
Yeah, we might have zoomed up.
It's a little bit before this one.
Before this
no,
one.
Before this one.
If you didn't see it, I have.
No.
There's a landscape page there. That
Yeah, there was another
keep going
landscape
up, you
there.
find it.
Up.
Keep going up. It might not have rendered.
There you go. There you go.
Here we
Good
are.
spot.
Yeah, if you can just shrink that slightly. So we won't go through the whole thing. It's really for another day. Really, we can cover these topics in our discipline. But the key points really to recognise are that there will still be procurement of vertical products, HVAC controls, lighting controls. We're not going to be changing overnight to that horizontal vision that Kathy had on her screen. We've got vertical systems, that's how our industry is structured, but those vertical systems will have clean interfaces, and so they'll be publishing data in a coherent way that can be ingested, either directly from the end devices or via a gateway device. And then that will go through a common building network. Again, that might be landlord network. Tenants may have their own separate networks due to leases on buildings not aligning with landlord. But both landlord, it's over on the left there, corporate network, landlord network and the corporate or tenant networks will have routes to the internet. And it's on the cloud services in the internet in data centers that are outside the building where our horizontal integration between systems and between buildings takes place, and also crucially between user interface devices like your phone and the building. Because all of those devices have access to the internet, it's much cleaner and much lower cost for us to do integration in the cloud than it is trying to penetrate through firewalls within the building. And so a typical route from device to lighting control will be via these authentication and apps that we install on phones or on websites, but they'll be operating in the cloud. That's all I wanted to say on the spec. We can have a discussion in a short while, but we want to take this debate and this conversation to MEP engineering teams via the skills networks. Tom. And again, not wanting to give people the impression that this is something that's for high-end projects or big budget projects. I just wanted to have an example of sort of conversation we could have on every project. And Tom, there's a PDF file that we can put on the screen. This is a project we did in our team B3 in London, Impact Centre in Edinburgh. And it was just as on the screen here, a discussion paper. We followed it up with a conversation with basically the discipline leads and the specialist leads on the project. And if you scroll down, first we identified systems where there might be an integration story on this project. And you can see on there we've got PA and CCTV, we've got HVAC and lighting. And then there was another list of systems where we weren't going to even bother talking about them. They're not even on the agenda. Fire alarm, voice alarm, typical life safety stuff, where we knew we were going to get bogged down on this relatively standard project, and there wouldn't be either a client ambition or in fact a technical feasibility for achieving integration of those systems. And then a table, and working from left to right, it's really business as usual on the left, vertically segregated, separately procured systems that we were familiar with, and over to on the right-hand side, a cloud integrated ambition of the like that we've been describing with MQTT and JSON publication of services state into the cloud. But in between, you know, the first step along, are there multiple IP networks in our building that we could say, well, let's not do that, let's have one landlord network for these subsystems? Can we put coherent naming into the spec on these systems? And can we use IP networks, and again, wired or wireless, instead of you know, BACnet, KNX, or Modbus type, like building-centric networks? And scrolling down, we actually went through subsystems. This is a, I'll hold it there, Tom, this is a public concert hall. And we've got a theatre consultant. And you'll notice house lighting, where we're doing the design, we've got a full ambition. We want to do a wireless lighting control system, either thread or Bluetooth. And we're going to spec some form of data publication from that system. So we're saying it's a 5-star ambition on lighting control. But the performance lighting control, same conversation with the theatre consultant. No, it's going to be a separate network. It's going to be conventional. We'll use Ethernet, but it will be limited to our products and our system. And so we are business as usual. We'll have RS485 serial bus to eliminate as well, DNX. So that's you know, one extreme and the other extreme within one project. And that's the sort of key point. This is about having a conversation within your projects, not by saying, you know, we're not trying hard enough and we should do everything, because on a real project we won't be able to do everything. Just a couple more examples. Public address, we're thinking about using IP loudspeakers so that they can be grouped and zoned more easily. BMS and energy network systems, again, we think we can do naming on that and publication of data. And incidentally, we won't necessarily be doing anything in the cloud in terms of apps. We're just enabling subsystems. It's relatively low cost, we feel, to get people to name things correctly and to publish data cleanly. It doesn't really cost. Once you've got over the conversation or the hill of getting the spec out the door, it doesn't actually cost much to implement. And that's really, you know, the example I wanted. We would like to find a mechanism to share this conversation with all our project teams. And I think that's it for the presentation, if we want to talk about these topics.
Thank you. Questions, anyone?
I had a question when you said sort of cost much. So does that, in terms of that example project you had, doesn't cost much in terms of the additional time and effort that we as Arup need to spend and therefore would want to charge to our clients? what about the additional cost that it then might cost the client in doing a different procurement route or narrowing down some of their options as to what they choose when they get there?
Well, we're going to find out, aren't we? You know, we can't even talk to the client about some of these questions because they're not sufficiently informed to even be able to express an opinion.
Yeah.
But most clients do want to future-proof their buildings. They don't want yesterday's technology for something that they're investing in for the next 20 years. So, yes, they do want to have their cake and eat it. They don't want it to cost more. And I think we should be quite bullish about our ability to implement smart technologies for less money. You know, we know that smart sensing networks going into buildings go in for about £30 a device with wide area, you know, mobile technologies for their uplink, and they're battery powered. Key thing is for low cost internet services, make it battery powered and make it linked to the internet, and that drives the per point cost down to less than £50. Whereas with our conventional installations, we know it's up at £600 a point to get the thing connected onto the system, for the same hardware value.
And that's onto a siloed system.
Yes.
Whereas the internet one has actually got more.
So it's cheaper and better. So yes, there is more cost somewhere in the construction chain, but overall, I think the overall story is very much and that's why I put the slide about productivity. It's very much about a 10 times improvement on the cost per device to get the data up there versus a business as usual approach.
You say getting data up there. So some clients, like you just mentioned, are informed and know what they want, and also are able, have capacity to use cloud-based solutions or to engage with IoT. Others are hardly managing to engage with a standard BMS system. However, they still want to be future-proof. So when it comes to we're developing a BIM model, or when it comes to connecting their future ambitions with their current capabilities, is there a mismatch there of we'd like to at least create a naming convention to enable a future connection to IoT and cheaper sensors, etc., even if you don't have to use it now? Or how does that kind of work, or are we just suggesting not proposing this kind of system with clients who are unable to use it?
Well, there are things we can do already, like standardizing on names is something that is so simple in a way as a concept, but it gets so hard to implement because it doesn't have the value in the industry to get pushed as a priority. But that one by itself would resolve so many of the problems that happen further down the line when someone else needs to look into the system and not understand anything. So self-documenting system that have good naming and relationship as well modeled, they can definitely help even solve issues that we have we've had for a long time and we still keep on having. So I think doing that review can help into highlighting those things. Maybe we can have as our some priorities of where we want to push this for our own making our projects better first, and for our clients as well. Yeah.
In terms of the lack of industry standardization. So at the moment, we're talking about this stuff, and it's really exciting and it can be done, but it's not standardized.
Mm-hmm. So a lot of the things, a lot of these things that are kind of presented, there are standards already. It's just that they come more from a sort of institutionalized type of standardization rather than some of those are from industry standardization if you look more at the IoT side. But let's talk about description of buildings, like smart data semantic web applied to BIM. Yeah. So BIM we're sort of following a lot on what providers of software give us, while not maybe investing much into using these data models to make our life easier in creating models maybe for operations, as an example. So this is a crucial element of investment that we could do now if we identify the importance of it. So part of this, I guess, is trying to show that we should, because it means it means keeping this thread essentially from design to operations, so as one element, and in the end, this can enable so many different things. Because once the data model is sorted, it becomes programmatic, and once it becomes programmatic, then you can create software that is across disciplines. So this idea that we do integration in the cloud on the data model becomes really simple. Yeah. So Google is a lot more. It looks much more into doing this horizontal integration at every single level. In our experience, we think that pushing it to do the integration at the top, but with good interfaces, pushing up essentially data, is a way that can be resolved now, and this is what very, very pragmatically we should be pushing this year, next year, in the next couple of years, until the industry catches up with.
And the keys to doing that are simple things like standardizing in anything, which we can identify now through.
Yeah, and also for us as a whole to get more. To upskill ourselves and understanding more about semantic web as an example. So semantic, so linked data in application to how to model building networks. So one typical thing that we do still, by hand, are schematics in buildings, and we could, for instance, create the data model all in linked data and just push a button and it gets drawn as an example, and then it becomes the program that runs the building in terms of how the flows are configured, which device is connected to which device. So the concept is quite simple. To apply it, obviously there are a few software projects that we can imagine to happen, but it can already simplify our own life, from the perspective of doing schematics as an example, that maybe we should address it.
But going back to Sajo's point about some clients, and I think it's most actually, don't want to touch the BMS. We are in the business of making this solving problems, and part of the problem we have to solve as MEP engineers and as an industry is making buildings easier. So the idea that we're going to put another layer of complexity, middleware in systems, it's out there actually. This is a competing idea we're in competition with. You don't solve smart buildings by putting, some intermediary layer on top of vertical systems that's going to tie them together in a bespoke fashion for each project. This is implemented, this is sold, this is available, it's specified by our colleagues. It's something we need to energetically promote in our conversations, and there's a different way of doing it. And you do it by cleaning up the subsystems once they are publishing in a way that is standards compliant, that solves the naming, the security, the authentication. Then it's not only much cheaper, low cost to do the integration, it's also more robust and resilient to change because you're constantly changing the subsystems. In a tower system where you've got middleware, whenever you make a tiny change to the lighting, you've got to reflect that change in the middleware, and it's expensive. Yeah. It prevents buildings adapting.
We need to avoid all this level of redundancy of configuration that at the moment is done locally in many different places, and that's why it breaks and it needs a lot of maintenance.
Question, I think it was very clear to see that there's actions for us on projects in terms of doing reviews. So pleased to see that example at the end there with the 5 stars. That's a very practical thing that hopefully all of us here and people watching the video will be able to latch onto and start conversations on projects. Also the idea of the generic spec made a lot of sense. I'm interested to hear what next steps are in terms of that sort of standardization around naming as a project in itself. So, Francesca, you're obviously in the middle of something with Google, but are there other projects that could be involved with or is already involved with that are worth just mentioning at a higher level?
Yeah, so I think, on the topic of linked data, we have personal membership of the W3C working groups. So me and Ken and Wright, for instance, as an example, so contributing to those discussion about linked building data. So there is a working group. I would imagine it would be strategic for Arup maybe to take
company.
a company membership, yeah. And maybe structuring a little bit more these ideas about how to inject this into project and learn from project and inject it back into the standardization. So that's one thing that I think is quite important. We are also actively discussing on mailing lists and contributing to emerging standards like Brick as an example, because that one has had quite a strong client push in the context of this project with Google. And so I think in terms of ontologies, for sure there is a space that we should occupy in terms of.
But we are only in an ad hoc, in sort of enthusiasm-based.
Right now, yes, we are, but
from individuals.
But I think there is an upskilling so that more people can do that. I think, and keeping this conversation, because the amount of reuse that we can do in project, is not reinventing the same idea for every single project or copy pasting and then changing. No, it is adhering to a standard that is under constant development and integration.
The test, I would say, of whether the naming system proposals that emerge are good or not is whether they are rapidly adopted.
Yes.
People can sniff for good and bad, when they see something. And I'm very encouraged by some of the material that's evolving to create. So it's about naming for machines and naming for humans. Slightly different problems. We haven't had time today to go into that topic. But the way you scale it through the building from a product to a instance of many of the same products, they all have naming conventions that need to be resolved. And I think the work is really good. I think it will go down well, but
we don't have
that will be the test.
I think
people receive it
asset tagging, asset tagging is an area that is huge. It's bigger than buildings. It encompasses IT systems and operational systems, but supermarket logistics. It is everywhere, right? But the way it is, I guess it is standardized to some extent in the topic of supermarket, like products. Like the problem maybe we face is that we want to tag instances. We want to tag instances of the same product around buildings, where they are. And
so the example, a can of baked beans in the supermarket, the barcode on it is always the same.
It's always the same.
Whereas with the light fittings, they need to be different.
So the problem I think we have is that achieving universal agreement, it might still be tricky. But asset management system, we've been through them. It's quite appalling actually to read them, because they specify the process, but they don't give any example. So they're very kind of void. And any manufacturer of asset tagging system can come up with an idea and say that it complies with the standard just by following the process. But with any example, so there's no standard. So the standard is not about standardizing really the language. It's about standardizing this kind of void, empty grammar that is very, very fluffy in a way. But the words are totally made up by every single one, as an example. So I think there's a point about proposing maybe something across the industry. But for doing that, we shouldn't propose it as and this is the Arup system. No, it should be something agreed. With other. If we want to do it at BIM level, it would be with all the other competitors we have. It needs to be a really open
Is it right to think
initiative.
that from a BIM perspective, then the IFC building smart platform is a good way in?
So,
which does have some involvement.
Yes, we do. So all this standardization committee, they look into different things. So one thing is the ontology, which is defining what a thing is. If it is a luminaire, if it is a switch, if it is a controller, if it is a valve, whatever it is. So a bit like what Brick also shows. These are the ontologies, the essence of things. A human is a human, a table is a table. All these sort of things. Then that's how we name things. And how we name things can go in very different ways. So an example, me and my wife spent months in choosing the name of our daughter, and any one of you maybe has taken time, and this takes time. In the end, we went for the shortest one, which I still think is a very good idea. The shortest and the one that is most international, right? And I think this actual idea is a very good idea for the next for what can be done internationally. But again, it needs to be discussed because it's not just the two of us doing it, but is a lot more. But the naming thing is exactly that. Is taking something that has an essence and attributing something that doesn't change. And her change, actually, her name, there might be a few of maybe not her, but me, for instance. I find a lot of other people that have the same name. So again, the reason for a machine global unique identifier is that one. That in the universe, there can only be that one. And it's, so there's a level of convention in identification, naming, labeling, and metadata that needs to happen, and I mean, it doesn't need to be a long conversation, but there needs to be a conversation, and it needs to be somewhere. So if we want to be proactive on that, we need to find the right channel to lead that together.
Yeah, just on naming as well, and attributing metadata to objects. So externally geolocation, but internally, what sort of standards for internal location of objects do you?
Yeah, so there's no. I mean, I haven't found in my any international standard. So it tends to be JSON objects with some sort of encoding that is made up, but it's possible to follow standards that come from Apple, Google. They all do it in their own way because they've gone and developed their own way of doing things essentially. So the standard is adhering to as many standards as possible right now. Yeah.
But even that's one of the simple ones, because as long as it's something sensible, translating it to something else is just geometry. It's just
lat long usually, and there could be something like that. And but I would say it's
And I guess we want to see. Sorry.
Yeah, there are two questions there.
In the past, we've had consultants do the design, put a naming convention. The contractor comes along, puts their own naming convention on it, and then the FM people come along and completely sort of throw that away and do their own thing. So it's a really important subject.
Yeah.
And I can see from you saying putting the data out there. So we're not actually defining anything necessarily at this point in time, any interoperability between the various siloed systems.
Yes.
But having that availability, because if you decide 5 or 10 years down the line you want to do something, you've had it. If it's all locked in or all in different ways, you've had it. You've lost the.
No, exactly. As I said, it was incredibly appalling when we did this research about asset tag. We thought there must be a standard. Someone must have thought about that. And actually, no. They just described the problem.
language.
Exactly. They say that someone must think of a naming convention. It's like a bit like that. And in this naming convention, there needs to be uniqueness, blah blah blah. But it's very very fluffy. Yeah. Sorry. Yeah.
I was just going to ask if you think there's a role that a regulator can play in this sector to kind of remove complexity and indecisiveness associated with this, and actually kind of drive it forward. Or do you think it would just be too constrictive and it would result in something that people don't like kind of making it so that every system has to be able to integrate in some way?
So I think for buildings, what I suggest, just having done this scan before, the link. So if we look really at ontologies, the linked build data working group on the W3C consortium, so the World Wide Web consortium, is the best place because of its authority and
But it's authority by consent, isn't it?
Yeah, correct.
This is the beauty of internet engineering and the World Wide Web. Its inception is that there were competing systems, but people follow the leadership of those and the quality of the work that those institutions do, rather than being compelled to subtle difference.
So I think
it's also important because it's global.
Yes.
So it would be really hard to get the UN to sort that out. So W3C is
Yeah.
is a better route.
I mean, one of the reasons why we always make this example of the internet, you know, is been working nicely because it has been standardized by essentially technical people who just want to solve problems. They're not debating about, you know, it's just sitting at the table and say, you know, what is better really to move forward. You know, request for comment, RFC, you know, people who are competent and willing to reply, they just reply, and you know, there is an educated conversation around. I mean, sometimes flames, but yeah, it's cool. So I think that is it. You know, just sitting down at the table technically and wanting to resolve problems. Other consortia might have political agenda because the manufacturing lobby, or you know, and we don't want to deal with that. I think that's the point. So we are trying to deal with that with Google in a way right now with this idea. But I could already see in that workshop a lot of this sort of dynamics. So that's why it's better to say we take this standard and we use it, and that's it. It has already been solved. Rather than asking, and how do we solve it? If you ask how do we solve it in a context like that, it never gets solved because the politics are, you know, yeah, exactly. So that's it's a different level. Yeah, it's better to work at the level of, you know, technical level. Yeah. No executives.
In Francesco, you spoke about possibility of absorbing the software practices in our design buildings in our industry. So what would be examples of that? Are you referring to, you know, agile Scrum methodologies? Would that impact the way we actually work?
Okay, yeah, that's a nice topic. Yeah, sure.
What were you thinking of specifically?
Yeah. I mean, specifically, I think, for instance, we are doing a specification here, but that specification could disappear, in fact, in the future, and it can just become the program that we run. You know, it could just become the code that runs the building. So that's maybe, you know, a bit, I don't know if it is utopian, but a bit further down. Actually, it's not impossible. Yeah, for instance, the topology of the system could just be a brick network or a linked data network, and that is what we actually
I think an important comment that relates back Kathy's point in the middle of the video, where she was saying that the construction industry work in a waterfall style. Well, I think that your comment also very much relates back to that, because she's referring to the fact that we do these early stage designs geared through, and then we lock things down.
Yeah.
And so at a fundamental level, as an industry, we are very, very waterfall.
Yeah.
In our contracting steps. Design that way. And
yes.
So, you know, finishing and walking away, we do it, contractors do it. And
everyone does it.
Everyone does it. So what you're pointing towards is potentially how it might affect us, is a role for us after handover increasing for many scenarios.
Yeah.
And you know, we design and we potentially operate some of these digital systems and, you know, improve them over time with others, but less of this sort of walking away sort of system.
Yeah. Okay.
Thank you.
Thank you very much
for joining. Yeah.